Alright, so before we talk about the runtime analysis of the MergeSort routine, let's now do some quick tracing together. And the input I have is an unsorted list that we start with over here. So that will be this list of numbers over here. How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8. The reason I'm counting is later on in the next part, when we do the runtime analysis, we will have to see exactly how many split and also merge we will need to do. These two aspects will definitely impact the running time overall. But we'll talk about it in the next part. For now, let's only focus on tracing. And I'm going to have some color convention over here. Whenever I want to do split, I'm going to use the green. Whenever I want to merge, I'm going to use the red. Okay, let's talk about it. Initially, I'm going to do a split. So I'm going to split into the left, which is unsorted, and also split to the right, that's also unsorted. You might be wondering, why am I using green for the split and red for the merge? Let me tell you. The reason is somehow the split is cheaper than the merge. That's why I'm using that as a green and merge as the red. That's something I can tell you as a look ahead. But we'll talk about it next part, about running time. Right, after the split, we're going to have, let's say over here, in the middle, right? So the size will be 1, 2, 3, 4, 5, 6, 7, 8. So we should really say 1, 2, 3, 4. So this will be a very equal split over here. So the first 4 elements should be over here. So 85, 24, 63, and also 45. No sorting has to be done at the moment. And also we got 17, 31, and also 96 and 50. Right? So these are the 4. And of course, we have to recursively sort the left half and then recursively sort the right half. And so we are not going to go onto sorting the right half until we are done with sorting the left half. That's really what the recursion is about. So let me just try to mimic the way recursion is going to work. So let's now see how do we recursively sort the left half. We're going to split it first. So we're going to split it into another 2 parts over here, right? Further left and further right. So that'll be 85 and also 24, 63 and 45. And now we need to recursively sort the left half. And then once it is done, we're going to recursively sort the right half and then merge them. So what we're going to do is, how do I recursively sort this half over here? We're going to split it. So I'm going to split it into 2 parts. Split it to the left and also split it to the right. Over here. So it's going to be 85 and also 24. And you can actually see in both cases, for the left and for the right, they are matching the base cases. If you remember back in the code, when the list size is equal to 1, in that case, we can simply just return the list, right? So this will be sorted automatically. This will also be sorted automatically. So what I'm going to do is, I'm just going to say this has been sorted, so that will be green. This has been sorted, that will be green. But we have to somehow merge them. So this is where we're gonna go on to the next phase. So when we try to merge them, let's try to see that. So we're going to merge these 2 sorted lists, 85 and 24. So it's going to conceptually replace, but at runtime, it may not be exactly replacing, but that's something I'll refer you back to the code. So it's going to become 24 and also 85, right? If you remember this merge routine that we spoke about earlier. So to really merge, that's something you will have to trace by yourself. If I want to merge the 85 together with 24, of course 24 should really come before 85. After this list over here will now be sorted. This part over here, this will be sorted. And the left half over here has been done already. Remember, we have to recursively sort the left over here. So this part is done and it's now the sorted left. So you can think about this part over here is the sorted left. But how do we get it sorted right? We have to recursively sort its left half and also recursively sort its right half. So what's going to happen is we're going to, as usual, split first. Split into the left and also split to the right over here. Okay, let's write it down. 63 and also 45. And like before, both of these will be matching the base cases, meaning that this will be sorted automatically and this will also be sorted automatically. So now we can merge. And when we want to merge, we're going to call the merge method. And how do we merge these two sorted lists? Well, obviously 45 should come before 63. So what's going to happen is we're going to conceptually replace this one over here. So that'll be 45 and also 63. So this list over here will also be considered sorted. And what should we do next? Apparently, you can see the sorted left and sorted right has been done. Meaning that in the code, we got sorted left, we got sorted right. So we should really merge these two. And when we merge these two, we're going to merge these two sorted lists. And we're going to merge again. And when we do the merge, we're going to conceptually replace this part over here by the merge version. What should that be? Well, let's see. 24 should come first, and followed by 45, followed by 63, and followed by 85. So this will be the sorted list that will be resulted from the various levels of recursive code that we just did. What have we done so far? From the original unsorted list, we said that we should really split it into two halves over here. That's the top level, right? And then this is what we got so far. We have just got the sorted left. That's what we have got. So you can think about at the top level, when we make the sort call, what we got was we split it to the left, we split to the right, and now we have got the sorted left. And the sorted right is yet to be done. That's something we got to do now, quickly. Okay, and let's see how we do the sorted right. Very similar as before. In order to sort this right half, right? You can see when we try to call to sort the right, that one there is a recursive call which will go back to the sort routine, meaning that we had to sort that right half into the left and the right, right? Just keep going for the recursion. Let's try that. So that means we're going to split it into the left and also to the right over here, which will be 17, 31, 96, and also 50, right? And before we can do sorting on the right, we have to make sure the left one is sorted and terminated. That's what we're going to do. In order to sort the left half, we have to further divide them into the left and also the right. That's what we're going to do. That will be 17 and also 31. And indeed, we are reaching the base cases again. This will be a sorted list. This will be a sorted list. So we're going to merge them. So we're going to merge them, which is going to be, in this case, 17 should really go before 31, right? But, I can still just do the conceptual replacement, right? Just to be consistent. So that'll be 17 and 31. So this will be the sorted left over here. So we can now move on to sorting the right over here, which will involve every time you want to do sorting on a particular half, you have to do split first. So we want to do the split over here, and the split is going to have 96 as one list and 50 as the other list. 96 and also 50. And again, these are base cases. This will be sorted automatically. This will also be sorted automatically. So we want to merge again back here. And what should that be? 50 should really come before 96 when we do the merge. Meaning that we should really get 50 and then followed by 96. And that'll be the sorted list. We got sorted left and sorted right. Well, we should really merge them to really get back to the top level sorted right. Let's now do that. So we're going to merge again. That one there is actually going to replace this conceptually. And that one there is going to be, let's see, 17 first, and followed by 31, followed by 50, followed by 96. Think about the big picture over here. Initially, this entire list is being called as arguments on the sort routine, or the sort method over here. And then we said that we should really split into left and right. So that's what we did. We split into the left over here and split into the right over here. And then we try to say we want to recursively sort the left and recursively sort the right, which will give us sorted left and sorted right. We try to recursively sort the left. Eventually, we got this sorted list over here. We tried to recursively sort the right, and what we got was sorted right over here. And once we got these two, will be the last step, which will be to merge these two sorted half. So it's going to be a final merge that we're going to do. Okay. Now, surprisingly, once you do the merging, you're going to get, let me just, for completeness, let me just do it. So definitely we're going to get 24. Okay, let me just use the red over here. So we're going to get 24 followed by, oh, actually not 24, beg your pardon. I think 17. 17 followed by 24 followed by 31 followed by 45 followed by 50 and then 63 and then 85 and then 96. You can also double check. So the final answer we'll get is this sorted list after performing the merge sort. It's a very high level tracing over here just for you to see the different stages for the merge sort. You definitely have to make sure you understand about the split to the two halves and then try to recursively sort them so that you will get two sorted lists and then you will try to merge them. It's really important to actually see that. Let me just try to highlight one particular level so you will see what you should really pay attention to. For this level, for example, you can think about for this level over here, specifically, just for this level over here. Okay, for this level over here, you can see once we split into the two halves over here, and then we're going to do some recursion, which is what's happening below, and then we're going to get two sorted lists over here, and then we're going to merge them to get the original list. That's kind of the lens you can actually use to focus. Alrighty, so that's about the tracing, and we also went over the Java code, and you should really study them carefully to make sure you really follow the details in the implementation. Unfortunately, we are running out of time for this week, so what I would like to do is let me save the last bit of the discussion about the MergeSort, which is about its runtime analysis, to next week. So next week, when I revisit lecture number 4 on recursion again, I'm going to resume by starting the discussion of the runtime analysis for the MergeSort. We're going to see how efficient MergeSort might be compared with the previous sorting algorithm we spoke about, namely insertion sort and selection sort. Alright, stay tuned, and I will see you next week.